and we're going to move on to Achim Haug from AirGradient, who is coming to us from Thailand. So certainly in his evening. And he's going to talk about, does air cleaning have a role in schools? No role without monitoring. So Achim, over to you.
Yeah, thank you, Paul. Can you hear me well?
Yes.
Okay, good. Yeah, so we are working since quite a few years with schools, especially in Thailand and China. And what I want to talk today is really why is monitoring really necessary? And then we developed a small model looking at two main factors. I want to present this, and with a lot of really practical information and experiences from the ground. And I want to start with something that just happened a few weeks ago. So normally we do a trial when we go into school, and one of the biggest international schools in Bangkok came to us and said, we want to monitor the air quality. And so we came in with 10 sensors for the trial. And then we were a little bit struck because they said they want to just put the sensors into common areas. I asked them, why don't you want to put them in the classrooms? And they said 2-3 years ago, we put in this fresh air system with ventilation centralized, and it was tested and it works just perfect. So we just need to focus on the common areas. So I said, look, let's just put one monitor in just to confirm that. And then when we measured the CO2, we actually got this one here. So that's 1 week of CO2 in a classroom. And you can see after an hour of operation in the morning or two, it just went beyond 1,000 ppm and really going very, very high. So when we basically presented these results to the building manager, he was totally struck and said, this cannot be. So they looked into the system, and it turned out that a few months ago, they had some maintenance, and they actually shut this duct that brings in the fresh air. So they were purely running on internal ventilation. So this is just an opener, basically, on why this continuous monitoring is really, really important. And I want to highlight a few other things that we basically all experience quite frequently. So one is what I said, airflow blockage. Sometimes these automatic systems, the fan are getting older, so they have maybe degenerate from their performance. Same with filters. Sometimes, schools want to save money on a filter, so they put something that's just not as effective as before, or filters getting blocked. What's often also overlooked is changes in occupancy. So the system has been designed, let's say, for small kids, and then suddenly, in their classrooms, you have, let's say, grade 11, grade 12 kids that just exhale maybe 3 or 4 times more CO2. And then obviously you need another system. What Nick already said, we often see indoor pollutants. 3D printers are generating a lot of fine dust. Then we have other things, laser cutters, makerspace, sometimes cooking, when they cook in the school. And often the buildings or the systems are not really designed with these things in mind. And I think one of also a very, very big factor is the human behavior. So especially in times where we rely on teachers opening windows or switching on air purifiers, sometimes they make noise, so somebody turns them down. So without monitoring, it's not really clear to see are these kind of instructions that we give to the teachers and the staff actually working. So with that in mind, we kind of looked, okay, how can we make the monitoring the most effective way? And what we developed is basically a method that on first sight looks very generic, and then I come into the specifics. So obviously you have the sensors that collect the data, send it to a central platform. The platform analyzes and basically identifies actions, and these actions are then basically fed back to people or systems responsible. So it can be, and I have some examples later on, it can be people that need to change their behavior, but it can also be systems like, for example, demand controlled ventilation. So that the monitor basically tells them, okay, CO2 exceeding like, let's say 1000 ppm, increase the fan speed to get more fresh air into the classroom. And then obviously this leads to improvements. And then there are two loops around that process. And one is really what we call active harm prevention loop, which is a real-time feedback loop. And I have some examples later on, and a continuous improvement loop where we look more at what's over the longer term, like how can we do like permanent improvements to improve the air quality. So a few examples on what we call active harm prevention. So one is, I think it's also something that came in very early after COVID started into classrooms in the UK. Basically this kind of, we call it traffic light indicator from Germany. And you have these green, yellow, red lights based on different ppm levels from CO2. And then, you can open the windows and try to get it back to green, basically. That's obviously a real-time measurement of the air quality. What we do often have here in Asia is pretty much every school has an air quality policy, mostly based on US EPA levels. And what we do is like, or these schools do, they monitor the outside air quality. And then like we have the system that, for example, if it switches from yellow to orange, that automatically, for example, to the PE teachers, a notification based on that policy comes that, for example, they should relocate, sports activities indoor into purified spaces, or keep an eye on sensitive individuals. So these are real policies that some of the schools use. Then some examples for the continuous improvement. So I think the most interesting thing is really like making I call it like an exposure analysis over a longer period of time. And really looking into details like what's the performance of like different classrooms, different types of rooms. Sometimes we look in like, do these classrooms use different types of ventilations? What's happening inside these classrooms? And we also often see differences depending on, let's say, the architectural layout. For example, here in Thailand, like schools are very air leaky, I would say, because we don't have this kind of cold climate. So what we often experience is that the top floors with just these kind of ceiling tiles to an open attic just get a lot more pollution in through these gaps, whereas the other floors with concrete ceilings are less affected. And I want to show you a practical example of a report that we do. So it comes to a management summary where we measure against WHO standards. This is from beginning of last year, so it was still like below 10 micrograms. And then we compare the indoor air quality to outside, for example. We look at different facilities, like, for example, sports facilities. And we look at different types of ventilation. So this school here, for example, has positive pressure systems in their main classrooms. And then we can see that they perform a lot better than, for example, air purifiers in the other spaces. And then this report goes really into, this is a real report here, into each classroom basically, looking at, this was 1 month in February last year. What is really the purification performance? That's basically the reduction to outside. And how does that compare to like WHO criteria? And I have one page where you can see quite different. So here we can see, for example, that the cafeteria obviously creates a lot of indoor pollution. So you can see they're pretty far away from reaching like the WHO targets. And we can also see that different purification technologies are just, for example, less effective than the positive pressure system, which keeps it really, really low, but the air purifiers maybe just reach like 50–60% of purification. Then what we do as well is then to create some kind of weighted average, which we're still discussing internally if there are better ways from a health perspective, but just assuming that the students spend 60% in their homeroom classrooms, 20% in sports facilities, 20% in like common areas like the library, for example, and then to really estimate what's the exposure of the student over the school day. And you can see here, like that school does, I think, the purification very well. So it's basically 10% of outside what they had in that period. And then we give recommendations to schools, what they can improve. And then also really looking at when is the next assessment being done. And this is something that we try more and more to do automatically on the platform. Then what's also important on this continuous improvement area is really like benchmarking, looking at different types of rooms, highlighting the worst performing rooms, communicating that information back to the teachers so that they can see, oh, nobody wants to have the worst room, so that they keep an eye on the air purifiers, switch them on, for example. That we call healthy competition, works pretty well on the ground. And then we also really look at what are external benchmarks. So for PM2.5 it's WHO, for CO2 it's more country specific, but it's, I think with COVID now it's probably around 800 to 1000 ppm what most countries recommend. So we try to bring this into, like, for example, our charts so that people immediately see, okay, this is the WHO annual air quality guideline. Are we exceeding this or not? So just to summarize that, really, like if you build up a monitoring system, really looking at both aspects, like what is this immediate harm prevention, also with COVID, I think very, very important. So as soon as the CO2 goes really high, make some immediate, basically preventions, either it's an automatic system that comes in more fresh air, or teachers that open windows or operate air purifiers. And then really looking at how can we reduce the long-term exposure of students to air pollution or high CO2. Yeah, that's my presentation. So if there are any questions.
Thank you very much, Achim. That's very interesting. And there are, again, no questions in the chat. If anyone would like to raise a question for Achim, please unmute yourself and speak. I'd like to ask a question about your positive pressure rooms. But these were presumably then not naturally ventilated, is that correct?
Yeah. So I mean, we are living in areas with really high, also fine dust exposure. So opening the windows at certain periods just makes things worse often. No? So it's really important for the positive pressure systems that you really have an airtight room and also very high performance filters, because unlike like an air purifier, we can have multiple runs through the filter. With a positive pressure system, we basically have to bring it to zero, just running it one time, the outside air through the filters, and then creating the positive pressure inside. So it's quite a different quality of system needed to achieve these results.
Yes, and I see Kath has her hand raised, so we have time for a question from you, Kath.
Can I just ask a sort of follow-up to that question? So can you achieve a sort of positive pressure ventilation across an entire school?
Yes.
Yeah.
So we have a sports ball with which we can actually bring to zero like particles. Even like sometimes here in Northern Thailand, we have 300, 400 micrograms, like, you know, kind of 50 or 200 times above the WHO. And the positive pressure system really kind of decouples the outside air from inside, because you have this positive pressure. So all your small gaps where the dirty air normally goes in, like under your windows, under your doors, it's kind of pushing it out. It's like you have a small hole in a balloon nothing can enter.
And it deals with, so therefore, you know, I'm just thinking of real life schools where kids go in and out all the time and open doors, leave them open and things like that. Whether there are practical challenges with maintaining positive pressure in a busy school.
Yeah. So we had, like, for example, when we like that gym that I just talked about, it was a multi-step process to really remove all the air leakage. They also had doors on opposite sides of the gym. So they actually had to close one door because they had this kind of cross ventilation. So it takes some effort, but once you achieve that, it's really digital. If the room is pressurized, it just drops down to 0. And then what we also combine it with this demand control ventilation. So let's say if a student leaves the door open for some time, but we also install door closers. I mean, that's another thing that is helpful with positive pressure systems. Then the system will just run on a higher level to try and bring it down quicker. And then once, you know, like PM and CO2 are within the target range, it brings down the fan speed and saves energy.
Thank you. I think we need to move on now. So Pete, I see you've got your hand raised. You could put your question in the chat, or you could raise it and we can try and answer it that way, or you can raise it during the breakout sessions if you wish. So I think we should now move on.
Question, actually, but it's a follow-on to Kat's question, but I can speak with her afterwards.
Yeah, thank you.